Hi, I'm Sanjana, and welcome to my Meta Hackathon submission. This project reflects days of exploration, data wrangling, debugging, and storytelling. I have structured this walkthrough into two complementary tracks. Track 1, the main track, how Kaggle users behave, from submissions timing to team dynamics to leaderboard strategies. And track 2, how Kaggle itself is evolving, trends over time, including programming languages, competition themes, and tool adoption. Let's get started. I have tagged the markdown to each code so that you can access the purpose of code and expression of the inside. First thing first, cleaning and structuring the data. I worked with over 40 CSVs from the Meta Kaggle dataset and they weren't ready to go. Each file came with its own schema, inconsistencies, missing counts, and formatting flags. So I built a data loading pipeline that audits each CSV file, drops columns with more than 50% missing values, converts key date fields like last submission date, creation date, and deadline date, and stores untouched backups in a dictionary called original data. And I felt it was necessary to visualize this. This is the visual representation of the missing values before and after cleaning. It literally demonstrates the importance of cleaning and structuring the raw data. This wasn't just cleanup, it was foundational for building analysis ready datasets across competitions, teams, kernels, and more. Let us take a look after my insights. Track 1, the main track, main hackathon insights. This track explores submission strategies, team size impact, overfitting behavior, and what makes a kernel go viral. My first insight, kernel engagement favors clarity over complexity. Using kernel CSV, I analyzed 10 most upvoted notebooks. Surprisingly, these weren't complex competition solutions. They were tutorials and walkthroughs, clean, annotated, and educational. The best engagement comes from teaching, not just winning. Most top kernels were authored by just two prolific contributors, reinforcing how much consistent content creation can impact on the community. And my next insight was public private score drift shows overfitting. From Team CSV, I compared public score to private score for each team and calculated the drift. Most teams had minimal drift. Median is almost equal to zero point 0.0 and the median equal to 0.0044. But a few showed a huge public-private gaps, which is more than one. This proves leaderboard overfitting is real and the private validation is crucial. Good public score doesn't always mean good generalization, I would say. My next insight was, is it last date was real or does it favor us? Let us find out. Using Team CSV and Competition CSV, I aligned each team's last submission date with the competition deadline. When I split teams into early versus final day submitters, the results were striking. And my insight was last day submissions ranked better. Teams submitting on the final day ranked nearly 8x better than those submitting early. On average, final day terms ranks around 116 and others ranks around 960. Maybe top teams doesn't rush. Maybe top teams don't rush. They iterate until the final hour. And my final insight in track 1 was solo competitors outperform teams. Now, isn't it surprising? Here I group a team by size solo 1 and small that is 2 to 3 people involved and medium that is 4 to 5 people involved and large where 6 or more people involved and then examine their private leaderboard rank. Surprisingly, solo competitors consistently perform best and Another surprise that medium-sized teams where 4 to 5 members were involved had the lowest average ranks. This challenged the assumption that collaboration always helps, doesn't it? Maybe solo players iterate faster, avoid coordination overhead, and pivot more freely. And now let us jump to track 2 trends over time. Exploratory track it is. In this track, I zoomed out to analyze macro trends across the Kaggle platform, languages, frameworks, competition topics, and user behavior. My first insight in track 2 was dataset usage follows global events. Let's find out how. Using dataset task submission CSV, and I plotted dataset task usage over time. There was a dramatic spike in early 2020. Yes, there was a dramatic spike in early 2020, a clear signal of COVID-19 effect. Kaggle usage surged during global lockdowns, then tapered off. Maybe Kaggle's engagement cycle is event driven and context sensitivity. Sure, it is. And my next insight was Python is dominant kernel language. Yeah, to extract the insight from language trends, it was very fun. I mapped kernel language IDs using kernel language CSV and kernel version CSV and plotted usage by year. IPython notebook skyrocketed, and while R steadily declined. Well, for my another insight, I needed an external validation and I collaborated with TIOBE Index. To cross validate my findings, I manually charted simulated TIOBE Index ranks from 2015 to 2025, and I found Python climbed from 8th rank to top 1 by 2021, where R fell from top 10 to 21. Here, Kaggle reflects global developer sentiment. Python is leading everywhere. And my next insight was to forecast Python and R growth with profit. Using simulated usage data, I modeled adoption trends using profit. Massive, right? Python is projected to hit 99% usage by 2030, while R may fall below 15. Python isn't just dominant, it's growing. That was fun to say hi to future. Well, now let us get into another insight that I extracted. Competition topics are evolving. Yeah, I created a synthetic data set to track 5 major competition types from 2015 to 2025. Computer vision, CV, natural language processing, NLP, tabular classification, recommender system, and time series. Now my insight was like this. NLP overtook all others by 2021. Tabular task declined, and CV remained stable. The future of Kaggle is unstructured data, particularly language. Let us say hi again to future and predict. Now let us forecast competition themes to 2030. Again using Profit, I modeled project competitions per theme, and my insight was NLP was almost equal to 65 and CV equal to 55 times series to 18. Well, I would say NLP is set to dominate future Kaggle competitions. And here is my bonus insight. Framework adoption mirrors ecosystem. Finally, I simulated tool adoption from 2015 to 2025. And my insight, and I would say Kaggle trends align with broader software engineering patterns, whereas Flask and Django grew with Python, React surged, Angular fell sharp. As I said, Kaggle trends align with broader software engineering patterns. My final thoughts. This notebook wasn't just about code, it was about storytelling. From strategic late submissions to solo modeling outperforming large teams, and from Python's continued rise to NLP overtaking the competition scene. This journey was about understanding how we model, how we learn, and where the community is heading. Whether you are a Kaggle grandmaster or just starting out, I hope this analysis sparks ideas about how to approach your next competition kernel. Thank you so much for watching. I'm Sinchana and this was my Meta Hackathon submission.